Let's see. Where did I leave off last time? I think I was doing easy binary search, which I could not solve. I think someone was helping me. I did finish it yesterday. Okay, I finished it yesterday. But I did get stuck. I think I had an issue where I had it as less than the right side, but it had to be like less than or equal to. And then I had these backwards. So yeah, and then I had to look back on the YouTube comments because someone had mentioned this was the formula to getting the middle of the array. Yeah. Interesting. Do light mode. Oh, nice. My camera's not working. Might have to return this thing. We'll see if it does it again. I'm gonna disconnect it. Maybe that's why it's doing it. I think that's fine. What is this? It's the it's the like DJI phone holder, and it's been acting up. It just like flips the camera upward. No idea what's going on with it. Let me look that up actually, because I think I might be close to getting out of warranty. Okay, it just says that the phone might not be positioned right on the clamp. So the weight, the motors can't handle the weight. That's all it says. I mean, technically it's in the center of the phone. Maybe the camera's too heavy, so I have to like slide the phone a little bit downward. Okay, if it does it again, I'm gonna do that, but there's no obstruction. So it also says like if there's an obstruction on the phone. Okay, I could fix it from the app. It says gimbal auto calibration. Okay, but we'll see. We'll wait. See if it happens again. So let's keep working on this. Do light mode, it's still sunny out there. Also, last time I was doing this, I was using like a for loop instead of a while loop. And I was thinking of like using recursion. Then the more I thought about it, it just didn't really make sense to like copy a subarray and then pass it onto the same method recursively until I get the solution. Yeah, it just didn't make sense. That, because you would have had to copy, I think it would have just made it like n log n. Yeah. Oh, dude, I think I was doing the wrong one. Which one is Carfleet? Carfleet, is it on here? I put on my list that I was gonna work on that one. Oh, there's Carfleet. Part of a stack problem. I guess we could try to do it. Okay, looks like I've solved it before. What? What are the parameters? Okay, I have it on my notes, but it's not, I think I have the wrong question here. In my notes, I have the title Carfleet, but the whiteboard that I have on there is for binary search. Put the wrong thing. I just delete that. See, we delete stuff. Oh, wait a minute. Yeah, I'll just delete it. Oh, nice. Okay, I'm gonna try to fix this real quick. I'm gonna run a break. Okay, I think I fixed it. We'll see. I think what it is yeah, that did not fix it. Yeah, try that. I put it on the charger and I think the gimbal doesn't like that. I don't know what other way to charge it. It usually doesn't last when I'm doing continuity. Hello. Hello. Okay, I got sidetracked hella hard. Just spent 30 minutes fixing my stream. All right, it's all right. So the next question, car fleet. I had it on my notes, so I think I'm gonna do that one. Let me just add it to my notes here. Just copy and paste it. What is the question? Okay, so you're given the position array and a speed array and a target. So position I is the position of the ith car in miles. Speed I is the speed of the ith car in miles per hour. The destination, that position target. Says a car cannot pass another car ahead of it. Can only catch up to another car and then drive at the same speed. A car fleet is a non-empty set of cars driving at the same position and same speed. Single car is also considered a car fleet. Okay, let's see an example. Okay, so target 10. I feel like I've done this question before. There's like an asteroids question similar to this. So the car starting at 1, speed 3, and 4, speed 2, become a fleet, meeting each other at this. What's the math behind it? Okay, let's look at this other example. Yeah, what's the math behind the car that starts at 4 and 7 becoming a fleet? What's the topic stack? Sorting monotonic stack. Okay, I'm gonna try to whiteboard this. Do we take this bigger example? Cool. I'm gonna draw them out. Yeah, when do they converge though? I'm trying to figure out. Okay, vehicle 0 is at the 4th mile. Actually, I don't know if this will help me. Okay, this is also 0. Wait, no. Who's 0? Yeah, no, this guy's not 0. This is card 2. This is 0. This is 3. I missed one. 1. I think that's it actually. Okay, let's see. Okay, so this one's going 1 mile per gallon. It goes miles per hour, right? Not miles per gallon. One was going 2. Zero was going 2. And this one's going 1. Wait, how are these not grouped? Oh, because this one outpaces it. How do we measure? How do we measure when they converge? Do we take the difference? Let's see. like that. Like that. No, wait. Is this right? So that's how many steps away they are from the target. If we do those steps, so for 0, it'll take 3 steps for car 0 to reach the target. Car 3, we take the difference divided by their miles per hour. So they'll both reach the target at the same time. Yeah, so car 3, by its 3rd step, it would be at the target, and so would car 0. I think this follows if we go to the other cars. Let's see. Car 1. Sorry, I was thinking. What's the distance? And then it's miles per hour, right? Like a fraction or something. Do the fraction. Takes 4.5 steps. Okay. I think that's the math. So let's see. We can calculate the steps that it takes for each car to get to the target. if the values, if other cars have the same value, then they will reach the target. They'll be part of the same fleet. I think that's what they called it, car fleets. And and each different time of arrival are their own fleets. Also, my camera hasn't acted up. It was like breaking. I think I can't charge my phone while I have it on the gimbal. Anyways, yeah, I think that's just, and it was saying something about stacks. Does the stack matter? It just wants to know how many fleets are gonna be. Maybe the stack does matter. What's the, okay, I'm not gonna worry about the time complexity. I think I'm just gonna do it like the way it's coming to mind. So let's see. Maybe I could add a stack on here. Well, wait, hold up. Yeah, so we first have to calculate the distance from the car's position to the target. So if we do like, I think it was, which one did I do here in the middle? I did 10 minus 7. I think that was car 3. Yeah, and then we get the distance from, yeah, we get the distance from its current position to the target. Then we divide that by its miles per hour, which comes from a different vector. But if we use a for loop, we're essentially in the correct position in the array. So let's see. So we can do a for loop, and we could grab from the positions array and from the speed array at the same time. So for the first one, oh, where did my mouse go? Yeah, for the first one, we'll do 4, right? Let's see. 10 minus 4. I think I did it right here. We'll do 10 minus 4. I think I need to draw the stack because I don't quite understand it. Let's see. I'm trying to draw it in my head and it doesn't make sense. I think if okay, so for this one, Yeah, we'll do this math first. So we'll do target minus, this is the one I'm looking at. We'll do target minus position I divided by, then be this one. Actually, that's the wrong one. Hold up. Who is car 0? Yeah, that's the right one. Hold up. So we do target minus position I divided by speed position I. I think that's the one. Yeah, then we get 3. We could put that into the stack. So something like this, I think. Let's see. Okay. Then we could go to the next one. What is that? Put it on here. Car 1. We get 4.10. Oh, sorry, 4.5. Then car 3, or index 2. That one was here. That one has 10. Oh, that's why they had to be in order. Okay, then the next one was 7. Why would it do that? Which was here. The stack doesn't really help us unless we sort the stack. Now I'm curious, what is the time complexity that they want us to solve it in? And log n. Wait, why would we even use a stack? Wouldn't it be better to use a map? Because then we could do, so where the key is the estimated time of arrival. So we could have, let's just look at the stack. So the first one was 3. We could put that in the stack because it's not, doesn't exist. And we can initialize it with 1. Then we have 4.5. 1. 10 is also 1. Then we get to 3. And then we could change it to 2. Yeah, then the order doesn't matter because we're keeping track of how many cars fall into the same fleet. So we could just iterate over the map, grabbing the K value, or actually, yeah, I think. What am I missing here? Wait, does it work for the other example that they have on here? Take a look. Okay, so we can do minus the position divided by, we could just do it here, divided by the miles per hour. Does that follow? I think that makes sense. I think that looks right. And then there's only one. We could grab the size of the map. I think I'm going to use a map. Oh wait, I'm not even showing the screen. Okay. Do we need anything else? Was it just vector? Oh, well, I'm using map, right? So. I think that's it. Thank you for that. Okay, I'm gonna use my spoon too. Courtesy of my girlfriend. Appreciate that. I'll put it to the side. Let me try to finish this. Okay, so we're gonna have a map. I'm gonna call it result. Oh, it's unordered. Anyone who does this. So we can iterate over, essentially we can iterate over positions and speed. I think they're the same size, unless I'm mistaken. I think they're the same size, right? Mentioned on here. Okay. Yeah, they are. So we can do position or speed. Doesn't really matter because they're the same size. Okay, the next thing is we want to find the time of arrival. The int ETA equal to target minus position at I divided by position. Oop, it's actually speed. A little messy to look at. I think that's better. Okay, this is where I need documentation because I can't remember. How do we put it in the map? Is it pushback? Is that just for vectors? I can't remember. But Google can help us with that. I've searched this like 3 times already. It's in my history. I feel like I have to build something with it, or just maybe code more problems. Is it getting dark? It feels like that in here. Too yellow. Maybe something like that. Also, it's too bright still. Yeah, we'll go with this one. I think that's fine. Insert. Wait a minute. I think we can do, well, I know how to insert. How do we check? Look up. Find element with a specific key. Contains. I don't think we can do contains because I think I have like version 17. What does this return? Okay, it returns and if it doesn't exist. So if we want to find ETA, if it's not equal to end, I think it is. Yeah, if it's not equal to end, then that means it's in the map and we can just increment the value. So we can say ETA is equal to, well, we could just say itself plus 1, right? I think we can do that. Is that valid? Or do we have to say I'm just gonna put it over here just in case it's the other way. It's one of these two. Of course we can use and. Or maybe that's not how you use it. That's all right, we can look at. Or maybe there's an example here. Let's see. Oh, we have to do the map. Okay, so that's if it's not in the map. Sorry, that's if it is in the map. I'm the one writing it, I can't even remember. Else, we just place it in the map and initialize it to 1. Okay, wait. Can you do size, dot size? Returns a number of elements. So in our case, size represents the number of fleets. Can we take one of the examples from the question? So target 10. I'm just gonna take this for now. Not very Vim of me to use use my mouse. What am I missing here? Oh, wait, this is a vector. Okay, what else? I still can't believe I spent like 30 minutes fixing my stream. I think I'm writing this correctly. So the answer should be, what's the name of the function? Car fleet. You know what? I might as well do with 3. Because I want to use the debugger. So okay, I got 3. And the answer should be 3. Okay, it passes that one test. Doesn't mean it passes altogether, but good sign. I think we'll run it. Yeah. Expected. Let's see. Okay, we'll take this one and run it on the debugger, I guess. The other one was, and the target is 12. Put it here. Put a breakpoint right there. That work? Yeah, there it is. Okay. It's hard to see. Okay, wait, what did we output? 4, but it's supposed to be 3. Why is it 4? Overcounting. It's overcounting fleets. Is it because? Oh wait, I know why. I'm using ints when I'm doing division. Let me stop this. And it should be float, or else it'll round it down. I think it rounds down. It rounds down or up, I can't remember. And so this should also be a float here. This is the same. Okay. Possible loss of position. I think it's fine. We'll run that again though. We should get 3. Still gets 4. Wait, did I save it? Okay, I did save it this time. Okay, maybe it's a different problem then. Maybe it wasn't that. I think that was an issue though. Because if you have like 4.5, is it going to turn into a 4? I think I'm going to use float. Yeah, I'm just going to run the debugger. Let's take a look. Well, hold up. Before we do this, can we figure out which one is it over counting? Let me do the math here. I want to figure out who it's over counting, because even I turned it into a float. So what's going on? But then on the other case, it passed. All right. Let's see. Wait, this one's actually. Yeah. Over 2. Okay, what's the next one? It's also 1. Wait, is it the 0 that's throwing it off? Okay, we have a fraction right there already. Okay. I always forget to share my screen. Anyways, I have 3, 4. Okay, wait, I have 4. Why do they have 3? unless I'm misinterpreting the question all the other times. Let me reread this a little bit. Okay, now I'm confused why it's supposed to be 3. Okay, we're going to consult the oracle. I wanted to explain the test case. Oh, magic oracle. Okay, let me put this ice cream in the fridge before it melts. Okay, what did it say? Wait, the car position 10. Right. Wait a minute. Position 5 takes 7 hours. Cannot catch the fleet ahead. Clear from new 2. Car position 3. Takes 3 hours. Oh, that's why the order mattered. If we look back at the question, okay, it's getting dark. Wait a minute. Not this. Let's say test. Okay, so their estimated time of arrival can be less than some other cars in the fleet, but because they can't pass each other, they become part of a different fleet. So for the first car can reach it Are they in order though? I'm assuming they are, right? So the first car can reach it in one. No, that doesn't make sense. They're in order by their miles, right? So the first one is 10. It's 1. Then the second one is 8. We have 5. I'm sorry, I got distracted. Then we have 3. Okay, so then we can group them. So for example, okay, 8 can reach it in 1 step, but car 1 can reach it in 1 step, but car 0 is ahead of it. Car 0 can reach it in 1 step as well. So they're grouped. So these guys are grouped here. Okay, so those guys are grouped. Let's see, car 3 can reach it in 3 steps. So it can't catch up to this purple group. So it's its own fleet. Car 4. Sorry. I'm mixing my numbers here. So car 3, it's this one. This is car 3. You can reach it in 7 steps. It cannot catch up to these, because these can reach it in 1 step, reach the target. So car 3 becomes its own fleet. This is car 3, by the way. Then car 4, we're looking for this one, and reach it in 3 steps, which is less than car 3. Remember, car 3 can reach it in 7. Car 4 can reach it in 3, but they can't pass each other. So this one can reach it much faster than this one. So this one gets stuck behind 3 and it becomes a group. And we look at car 2, that is this guy here. Car 2 takes 12 steps, which is slower than these guys. So their order comes from here, where they're positioned relative to the target. So the position vector is what defines whether one car will become part of a fleet, a different fleet, or whether it will be its own fleet. So let's see. Oh no, now it's different. Okay, I think I'm gonna stop here though. And then we'll come back to this tomorrow. I'll think about it. I'll sleep on it. Maybe a stack makes more sense. I think one of the topics was like monotonically increasing, decreasing, something. Monotonic stack. Okay, sorting. Right, if we sort by position. So we can do something. What about a map where we have, what if we do this? We'll do a map. Yeah, we'll do a map. The key is going to be position. Is there duplicate positions? Hope no. Okay, positions are unique. This is good. So and then the value is going to be ETA. technically there's no duplicates. That's what the problem says. They're all unique, our positions. So let's see if we fill this. So we could get something like, well, it'll be the order in the array that the array is in, which is, let's see. Okay, give me a second, I guess. We have 10, 8, 0, 5, 3. And then I calculated these already. So for 10, have 1, and we have 1. For 0, we have 12. And for 5, we have 7, 3. Then what happens if we sort the map? By key. I think that's what I said. I said it was if it was by key. We do 0, 3, 5, 8, 10. 0 is 12. 3 is 3. 3 is 3. That doesn't make sense. Yeah, 3 is 3. 5 is 7. I don't know, something like that. Maybe a stack is better. I'm not too sure. 2 stacks? I don't know. But we'll leave it there for now. And we'll come back to this tomorrow.